What's going on, Math 2? We got lesson 2.3.2, determining similar triangles. All right, so in 2-90, we're going to check to see if the triangles are similar, and if they are, we're going to make a flowchart proof. Remember the similar triangles, the angles are congruent, and the sides are proportional. And we have three different ways to prove they're similar. We've got angle-angle similarity. We've got side-side-side similarity. And we've got side-angle-side similarity. So those are the three methods for proving that the triangles are similar. Remember, there were 5 methods for proving that they're congruent, but there's only 3 methods to prove that they're similar to each other. Anytime you see angle on this, they have to be congruent. Anytime you see side on this, you're going to say that they're going to be proportional instead. So on this one, I can't use side, side, side. I do have all 3 sides here, but I don't have all 3 sides here, so I can't do that. I mean, technically, I could probably do the Pythagorean theorem and try to do that, but I'm not going to. So what I do have is I've got an angle here, and I've got the sides on either side of that angle. So I'm going to try to use side, angle, side, but now I have to see if those sides are proportional. So looking at these 2 legs, 16 is the biggest leg from that triangle, and 12 is the biggest leg from that triangle, so they correspond to each other. Now that reduces, 4 goes into both these numbers, reduces to 4/3. If these triangles are similar, I should be able to take this corresponding part of 12 and compare it to 9 over here. Those are the smaller parts of the legs, and they should reduce to the same number. Now 3 goes into both of these, so I get 4/3. So we've just proven that since the corresponding parts reduce to the same fraction, then they must be similar to each other. So we proved that this side was similar to this side, and this side here is similar to this side here, because they broke down to the same proportion. Now remember, I decided which one corresponds because I was looking at the legs. I said, okay, the biggest leg here should correspond to the biggest leg there. So that's where I got the 16/12. And then the smallest leg here should correspond to the smallest leg here, which is where I got 12/9. So it looks like we can do side, angle, side because we've got right angles in between. Everything's good. So let's start with this tick mark side over here. We're going to write a flowchart proof. It's going to be hard to get all the everything in here, but let's go ahead and do it. So we know that HI over JL, we know that it reduced to 4/3. And that's a calculation that we did. So I'll just write calculation. All right. And then we have these sides are right angles. So angle H is right, and angle L is right. Those 2 pieces of information are given to us. So I know now that if both of these are right angles, then that must mean that they're congruent to each other. So I can say that angle H is congruent to angle L. And this is a new kind of statement that I'm going to put here. I'm just going to say all right angles are congruent. So if they're right angles, that means they're 90, and both of these are 90, that means they're congruent to each other. So all right angles are congruent. Okay, so I got a proportional side, angle, now I have to do the other proportional side. And that's one where I did HG. Running out of room here. HG over LK. Also reduced to 4/3. We did the work over here. We did our calculation. So that's another calculation we did. Calculation. I can't even spell today. Calculation. All right, so now I have a side that's proportional, an angle that's congruent, and a side that's proportional. So now I can say that triangle IHG is similar to triangle, let's see, I is between the one squiggly and the hypotenuse. That means that it has to correspond to J. H was the 90 degree, so it corresponds to L, and then K. And the reason we use side angle side similarity. All right, next one. So for this one, we don't have any angles on it, so we have to try to see if the sides are proportional. So side, side, side would be the only option for this one since there's no angles. All right, so let's see. I've got the biggest one is 14. And then the biggest one over here is 7. So 14 would correspond with 7. That reduces to 2 over 1. Medium size is 9. Medium size over here is 5. 9 over 5 does not reduce to 2. It reduces to 1.8. And then the smallest side was 8 over here. And the smallest side over here was 4. That does reduce to 2. These two reduced to 2, but this one did not. So therefore, they are not similar. All three of them would have to reduce to the same exact scale factor in order for this to work. So since the 9 and the 5 did not work, we can't say they're similar. Now, if this said 10, and we could get 10 over 5, 10 over 5 would have been 2, then they would have been similar. But this was 9 instead of 10, so not similar. Whew, we don't have to do a proof on that one. That makes it nice. All right, this one. We've got an angle here and an angle here. So we got one angle. And looking at these two triangles, I actually have a second angle. Angle M is the same on both triangles. That's a reflexive property. So on the small triangle, I've got this angle and my reflexive property. And on the big triangle, I've got this angle and the reflexive property. So this is angle, angle. All right, so we're going to use angle, angle on this one. So first, I'm going to say that angle V is congruent to angle this one. I can't call it angle S because there's multiple angles there. So I'm going to call it NSM. All right, there's my first thing. So that was given to me. And then over here, I've got angle M. Angle M from the small triangle is the same as angle N from the big triangle. So I can say that angle M is congruent to itself, angle M. And that is the reflexive property. Reflexive property says anything is congruent to itself. So using these two statements, we can now say that the triangles are similar. I'll start with the smaller triangle, MSN. Is similar to triangle, and the bigger triangle would be M because M corresponds to M. Those are the reflexive property. And then S was the one tick mark angle, so V goes with that one. So it'd be MVT. And we used angle, angle, similarity. There we go. All right, next part says, for the diagrams in the previous problem, find these measurements, JK. All right, JK, which one? Okay, this is this one over here. So find JK. Well, we already kind of have a scale factor here. We said when we compared the two triangles, comparing this one to the smaller one, they should reduce to 4 over 3. So I'm going to start off with that ratio of 4 over 3. Now JK is from the second triangle, that's the smaller one, that goes in the denominator. The big triangle we put in the numerator, the small triangle we put in the denominator. So I'm going to put JK down here. And now I have to see what corresponds with JK. Now JK was the hypotenuse here, so that should correspond with 20 right there. There's a couple ways that you can get your answer. If it's a simple problem like this where you can see 4 got multiplied by 20, 4 got multiplied by 5 to get 20, you can just say, okay, 3 gets multiplied by 5 and JK would be 15. Now that's if it's a number like just a round, an integer that we're multiplying by. Sometimes it's not that easy. So what we would do in those cases is use cross products. So we do 4 times JK. So 4 times JK equals 3 times 20, 60. And then we divide both sides by 4, and we still find out that JK is equal to 15. VT. VT was from this triangle here. Okay, so let's compare the small to the large triangle here. First thing I need to do is get the scale factor. And we find the scale factor by looking at sides that are corresponding to each other. So I can see here that this side of 9 from the small triangle should correspond with this entire side right here. That would be 2.5 plus 9. So that'd be 11.5. So there's my scale factor. It's not reduced, but good enough. All right, so we know that that should correspond. We're looking for VT. VT's from the large triangle, so that belongs in the denominator. And VT corresponds to this side SN, so we're going to put 5 up there. Now this one's not as obvious what our answer is going to be, so we're going to go ahead and use cross products on here. So I'm going to do 9 times VT equals 11 times 5. What is that? Is that 56.5? Or is it 57.5? No, 57.5. Okay, now I'm going to divide by 9. I've got to grab a calculator for this one. So 57.5 divided by 9 gives me, ooh, that's interesting. So I get a number that's a repeating decimal. It comes out to 6.38 repeating. So that's the exact answer. You might want to like reduce it if you, or not reduce it, round it. If you decided to round it, remember you'd use the little squigglies to show that you're rounding, and we might round that to 6.4-ish. So the actual answer is 6.38 repeating, and the rounded answer would be 6.4. Tn. So we want to find Tn here. On this one, Tn is not the entire side. The entire side from T to M for the large triangle would be Tn plus 11. So when we're setting this one up, we're still going to do 9 over 11.5 because that's the scale factor. The small triangle is 11. And then the big triangle is Tn plus 11. So when we do this one and we distribute, we have to do 9 times Tn plus 11. So that would be 9 times Tn plus 99. So we're distributing there. And then 11 times 11.5 is 126.5? I think it's 126.5. We would subtract 99 from both sides, and we get 27.5. So 9 times Tn equals 27.5. And then we divide 27.5 by 9. Here's another decimal answer. So 27.5 divided by 9 comes out to 3.05 repeating. So Tn would be equal to 3.05 repeating. So I would probably round that one, but if I'm going to round, I'm going to want to use my little squiggly lines, and I'd probably call that 3.1 when I'm rounding my answer. So the exact answer would be 3.05 repeating, and the approximate answer is 3.1. All right, next one says, write a flow chart showing that the triangles are similar. All right, so we've got this angle right here. We don't have three sides, so we can't use side, side, side. We don't have two angles, so we can't use angle, angle. So the only thing that we can use is side, angle, side. So the first thing that we need to do is go ahead and match up the corresponding parts. The biggest one over here is 23, and it corresponds to the biggest one over here, which is 23. So the scale factor is 1. The smallest one over here is 17, and the smallest one over there is 17. Scale factor of 1. So they are similar by side, angle, side. Now technically, these are also congruent. Remember, when you have a scale factor of 1, that means they're actually congruent to each other. So these are both similar and congruent to each other. But they want a flow chart showing that they are similar. So we're going to do it very similar. We're going to do it a lot like that very first one that we did at the top of the page. So we would say PQ over, we matched it with XY, came out to 1. And then we know here that angle Q and angle X are congruent. So then remember, this reason was calculation. And then over here, we know that these two angles are congruent because they marked them. That's given to us. So angle Q is congruent to angle X. That is given to us. And then lastly, we know that DQ over XZ, we saw over here that that reduced to 1. So that's a calculation. And here we've got proven that they're similar. We've got the sides, and we're proving that they're proportional to each other. They reduce down to the same number of 1. And then we've got a congruent angle in between. So using these three statements, I now know side, angle, side. So I might start with triangle PQD. That would be similar to triangle. Now P is between the 23 and the blank. So over here, Y is between 23 and blank. So P and Y go together. Then Q was marked and X is marked. So Q and X go together. And of course, the last one, D is between 17 and blank. So over here, Z is between 17 and blank. And our reason is we use side, angle, side similarity. Now, technically, we could have proven they're congruent, and we would have proven they're congruent by side, angle, side congruence instead. But since they had a scale factor of 1, we can also prove they're similar at the same time. All right, backside, almost done. Make a flow chart to prove the triangles are similar. All right, let's see what we have here. I've got all three sides on this one, but I don't have all three sides on that one, so I can't use side, side, side. I've only got one angle here. So I have two angles on this one, but I have only one angle here. So that means I can not use angle, angle, because I would need two angles right here. So we're down to side, angle, side again. So let's go ahead and look at RN. That's the biggest. So I'm going to try to prove that these two sides and this angle right here. And this one, I'm going to try to prove these two sides and this angle right here, because the angles are both 47. So looking at these two sides, 16.4 is the biggest one. So that is RN. So RN should correspond to the biggest one over here, which is 8.2. That's CT. So looking at that, RN was 16.4. and CT was 8.2, and 8.2 goes in there twice, so my scale factor is 2. Looking at this other side, RU, and looking at the smaller side over here, CA, they would correspond to each other because they're both the smallest sides on either side of that angle. I've got 8.4 over 4.2. And those also reduce to the same scale factor. So now I have proportional sides because they're reducing to the same scale factor. So writing our proof, we could say that Rn over CT is equal to, we said over here is equal to 2. We can say that angle R is 47. And we can say that the measurement of angle C is 47. And since those two angles are equal to the same number, we can now say they're congruent to each other. So we would say angle R is congruent to angle C. I haven't been writing my reasons. This was given. This is given. This was calculation. And then this one is just the definition of congruence. Congruence means that they have the same measure. So they do have the same measure, so that means they're congruent. So definition of congruence. All right, so I've got side, angle, and then the last one was RU over CA. We found out that that reduced to 2 down over there. So that was a calculation. And now I have enough to prove that they're similar to each other. I can say that a triangle, let's see, let's do run is similar to triangle. R was the 47 degrees, so that goes with C. U was between the small side and the unmarked side, so that would go with A because A is between the small side and this other one we didn't use. So it looks like we got run cat. And that is by side, angle, side, similarity. Charles wrote that triangle cat is similar to triangle run as his conclusion, but Nisa wrote triangle NRU is similar to triangle TCA. Who's correct? Well, it looks like Charles is right. He just did a different order. He just put cat before run, so that doesn't change anything. So Charles, good job. You are correct. Let's look at Nisa. Nisa has N corresponding with T. So N and T. Yes, those two do correspond to each other. N and T correspond. Then she has R going with C. R does go with C, so that's right. And then she has U going with A, and U does go with A. So she's right too. They're both correct. As long as you're matching up the corresponding parts in your similarity statement, you are correct. You don't have to put it in a specific order, but if you start with run, you have to end with cat. If you start with cat, you have to end with run. If you start with NRU, you have to end with TCA. So it all depends on what you started with and then matching up the correct parts on the second triangle. Find all the missing side lengths and the angle measurements of the two triangles. Okay, so we were missing the measurement of angle U. We're missing the measurement of angle N. We're missing the measurement of angle T. Let's start with the angles. So over here, A was 103, and we said A and U correspond to each other. So U has to also be 103 because the corresponding angles are congruent in similar shapes. So U would be 103. And now using triangle sum theorem, I can find out how many degrees this one should be. These two together add up to 150 degrees, so this one must be 30 degrees. So angle N is 30 degrees, and N corresponds with T, so T should also be 30 degrees. And we could use triangle sum over here to prove that as well. All right, now the only thing we're missing is AT over here. Wrong color. So let's go ahead and get our scale factor. We already have a scale factor. We did Rn over Ct. Rn over Ct, that was the big triangle here compared to this one. And we got that 16.4 over 8.2 reduced to 2 over 1. Now AT is from the small triangle, and we were putting the small triangle on the bottom. So there's AT on the bottom. On the top, we would put the big triangle, and AT is the last two letters, so it should correspond to UN, the last two letters. So UN would be this bottom here, and that would be 12.3. So if I do cross products, I would do 2 times AT equals 12.3. And then if I divide by 2 on both sides, let's see, 6.15 is what my answer would be. So AT is 6.15. There you go. There's our notes. Math hard. See you guys later. Bye. Stop.